Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. In this video, we'll introduce you to the developer tools available within AWS that help you build, test, and deploy applications more efficiently. We'll look at services like AWS CodeCommit, CodeBuild, CodeDeploy, and CodePipeline, and explain how they fit together to automate and streamline your software development workflow. Let's get started. In today's fast-paced development world, automation and agility are key. AWS Developer Tools are purpose-built to support the entire software development lifecycle, from writing and storing code to building, testing, deploying, and monitoring applications. Whether you're working on a simple web app or managing a complex microservices architecture, these tools are designed to help you move faster and more confidently. At their core, these tools embrace DevOps principles. They support continuous integration and continuous delivery, or CI/CD. That means you can automate repetitive tasks, integrate testing into your pipeline, and get rapid feedback, so issues are caught early when they're easier and cheaper to fix. Security and compliance aren't afterthoughts here. Each tool is built with AWS Identity and Access Management, or IAM, at its foundation, giving you fine-grained control over who can access what and helping you maintain compliance from day one. The pricing is simple and pay as you go. You don't need to worry about upfront commitments. You only pay for what you use, making it a cost-effective option for teams of any size. These tools also integrate natively with the broader AWS ecosystem. That means you can easily hook into services like Lambda, EC2, ECS, EKS, and many others, helping you build and deploy in a fully cloud-native way. And you're not limited by language or framework. Whether you're writing in Java, .NET, Python, Node.js, or Ruby, AWS Developer Tools are language agnostic and flexible. Finally, for teams with custom workflows, every tool offers extensive API support, so you can integrate them into your existing systems with ease. Now that we've set the stage, let's take a closer look at the key services that make up the AWS Developer Tools suite. These tools are designed to work seamlessly together, covering every stage of the software development lifecycle, from writing code to monitoring it in production. We begin with AWS CodeCommit. CodeCommit is a fully managed source control service that hosts secure, scalable, private Git repositories. It's designed to work just like the Git tools you already know and integrated with IAM for fine-grained access control. Next is AWS CodeBuild. This is a fully managed continuous integration service. It compiles your source code, runs automated tests, and packages your application, so you can catch issues early and deliver high-quality software faster without managing your own build servers. Then we have AWS CodeDeploy. CodeDeploy is an automated deployment service that helps you safely and efficiently deploy your code to Amazon EC2 instances, AWS Lambda functions, or even your on-premises servers. To tie it all together, there's AWS CodePipeline. This is a fully managed continuous delivery service that lets you define and automate your release workflow. You can easily orchestrate each stage to be triggered automatically every time your code changes. For managing software packages, AWS Code Artifact provides secure and scalable artifact management. Code Artifact helps you securely manage your dependencies in a centralized versioned repository. Then there's the AWS Cloud Development Kit, or CDK. This powerful tool lets you define your cloud infrastructure using familiar programming languages like TypeScript, Python, Java, or .NET. Alongside CDK, AWS CloudFormation is another cornerstone of infrastructure as code, enabling you to define your entire AWS environment using declarative YAML or JSON templates, great for repeatable, consistent, and automated provisioning. And finally, AWS provides a range of supporting tools to round out the developer experience. AWS Cloud9 offers a cloud-based IDE. AWS X-Ray helps you trace and analyze your applications to identify performance bottlenecks, while Amazon CloudWatch gives you powerful logging and monitoring capabilities. Let's now take a closer look at AWS CodeCommit, a powerful and fully managed Git-based source control service. With CodeCommit, there's no infrastructure to manage. AWS handles all the back-end provisioning, so you don't have to worry about setting up or scaling servers. Whether you're a solo developer or part of a large enterprise team, CodeCommit grows with you automatically. You get unlimited repositories with no size limits, which means you can store not only your source code, but also binaries, documentation, and any other project files, all without worrying about space constraints. Security is a top priority. CodeCommit encrypts your data both in transit and at rest using KMS. You also get fine-grained access control through IAM, so you can define exactly who can do what in your repositories. In terms of reliability, CodeCommit is built with high availability in mind. Your data is automatically replicated across multiple AWS facilities, helping ensure durability and access even in the event of infrastructure failure. For modern development workflows, CodeCommit supports advanced branching and merging. You can use feature branch workflows, create pull requests, and conduct code reviews right from the console or your preferred Git client. To help you integrate with your CI/CD pipelines or custom workflows, you can configure notifications and triggers. For example, you can use Amazon SNS to send alerts when code changes, or hook into AWS Lambda to trigger custom actions on push events or merges. And finally, CodeCommit works seamlessly with popular IDEs and Git tools. Whether you're using the AWS CLI, Visual Studio Code, IntelliJ, or standard Git command line tools, you can connect and work just like you would with any Git repository. Unfortunately, AWS has made the decision to close new customer access to AWS CodeCommit, effective July 25, 2024. AWS CodeCommit existing customers can continue to use the service as normal. Now let's dive into AWS CodeBuild, a powerful and fully managed build service that helps you automate the process of compiling your source code, running tests, and packaging your applications, all without having to manage your own build infrastructure. With CodeBuild, there's no need to provision, manage, or scale build servers. It handles the heavy lifting behind the scenes. Whether you're running a single build or hundreds of them in parallel, CodeBuild scales automatically based on your workload, ensuring high availability and performance without any manual intervention. It supports a wide range of popular build tools and environments right out of the box. Whether you're using Maven, Gradle, NPM, or pip, CodeBuild provides pre-configured environments that are ready to go, helping you get up and running quickly. CodeBuild also allows you to define your own build environments using Docker containers. You can create a fully tailored build image with your specific tools, dependencies, and configurations, giving you full control over the build process. For those who prefer not to start from scratch, CodeBuild offers a variety of pre-built environments for major programming languages like Java, Python, Node.js, Ruby, Go, and .NET Core. These environments are updated and maintained by AWS, reducing your overhead and letting you focus on your code. CodeBuild also supports parallel build execution, meaning you can run multiple builds at the same time. This is especially useful in large projects or teams, where faster build cycles lead to faster releases. To further improve performance, CodeBuild includes build caching, which stores and reuses dependencies between builds. This can reduce build times by up to 80%, significantly speeding up your development feedback loop. And just like other AWS developer tools, CodeBuild is cost-effective. You only pay for the compute resources used during the build process. No idle charges, no long-term commitments. Let's now explore AWS CodeDeploy, a fully managed deployment service that helps you automate code deployments across a variety of compute platforms. CodeDeploy is designed to make deployments safer, faster, and more reliable by removing the manual steps and reducing the risk of human error. One of the key strengths of CodeDeploy is its support for multiple deployment strategies. You can choose from in-place deployments, blue-green deployments, or canary deployments, each offering different trade-offs between speed and safety. These options help you minimize downtime and reduce the impact of potential issues during rollouts. And if something does go wrong, CodeDeploy includes an automatic rollback feature. If a deployment fails due to a script error, failed health check, or other condition, the service can automatically revert to the last known good version, ensuring your users are never left with a broken experience. You'll also get detailed deployment tracking and history. This means you can monitor deployment progress in real time, view logs, and maintain a full audit trail of who deployed what and when. Perfect for both troubleshooting and compliance needs. To help customize your deployments further, CodeDeploy provides lifecycle event hooks. These hooks let you run scripts or commands at specific stages of the deployment, giving you full control over the process. You can also use traffic shifting controls to manage how traffic is directed during a deployment. This allows for gradual rollouts, where only a small percentage of traffic is sent to the new version initially, and more traffic is shifted over time once stability is confirmed. Finally, CodeDeploy is designed to integrate easily with your existing CI/CD systems, such as Jenkins, GitHub Actions, GitLab CI, and of course, other AWS services like CodePipeline. This makes it simple to plug into your current workflow and start automating deployments right away. Next, let's talk about AWS CodePipeline, a fully managed continuous delivery service that helps you automate and orchestrate your software release process from end to end. At its core, CodePipeline provides a visual workflow designer that makes it easy to build and manage your release pipelines. You can define each stage of your pipeline, like source, build, test, and deploy, through an intuitive visual interface, giving you a clear and real-time view of how your code flows from development to production. One of the biggest advantages of CodePipeline is that it can automatically trigger execution every time there's a change in your source code. You can also add custom approval actions into your workflow. These human approval steps are useful when you want to pause the pipeline and have a team lead or QA engineer review a change before it moves into staging or production. CodePipeline also supports pipeline as code through CloudFormation integration. This means you can define your pipelines in YAML or JSON templates, store them in version control, and manage them like any other part of your infrastructure, bringing consistency and repeatability to your DevOps workflows. For speed and efficiency, CodePipeline allows parallel action execution. If your build and test processes don't depend on one another, you can run them side by side, cutting down on wait times and accelerating delivery. CodePipeline also plays well with others. It offers native integrations with third-party tools like GitHub, Bitbucket, Jenkins, and many more. Whether you're using open source tools or commercial platforms, you can easily plug them into your pipeline stages. And finally, for organizations with more complex architectures, CodePipeline supports cross-account and cross-region actions. This means you can deploy to multiple AWS accounts or regions, enabling centralized CI/CD pipelines that support multi-environment and global strategies. Now let's take a closer look at AWS Code Artifact, a fully managed service designed to help you store, manage, and share software packages and dependencies used in your application development. Think of Code Artifact as your centralized artifact repository, a secure, scalable place to keep all the packages your applications depend on. It supports popular package formats like Maven, NPM, PyPI, and NuGet, making it a single service to manage all your artifacts. One of the most powerful features of Code Artifact is its ability to connect to upstream repositories. This means you can automatically pull packages from trusted public sources like Maven Central, the NPM Public Registry, or PyPI, while caching them locally for faster and more reliable builds. Security is built in from the ground up. With fine-grained access control using IAM, you can specify exactly who can publish, update, or download packages. This is critical in large teams or organizations that need strict control over software supply chains. To ensure compliance and build reproducibility, Code Artifact enforces immutable versioning. Once a package version is published, it cannot be modified, helping you maintain reliable, repeatable builds and a consistent history of changes. Searching for packages is easy thanks to automatic metadata indexing. You can quickly locate packages using attributes like version number, description, or dependencies, saving time and reducing errors. Code Artifact also supports retention policies to manage the lifecycle of your artifacts. You can define rules to automatically remove old or unused package versions, helping you optimize storage and stay within compliance boundaries. Another important concept in Code Artifact is the idea of domains, which help you organize repositories along team or organizational boundaries. This allows different teams to work independently while still sharing common dependencies through a controlled and structured setup. When it comes to provisioning cloud infrastructure, AWS CloudFormation is one of the most powerful tools in the AWS ecosystem. With CloudFormation, you use declarative templates written in JSON or YAML to describe everything from networking components and compute instances to security policies and serverless functions. These templates are version controlled, just like application code, which brings consistency and traceability to your infrastructure. One of the key features is change sets, which allow you to preview how a proposed update will affect your existing infrastructure before you actually apply it. This helps reduce the risk of unintentional disruptions during updates. As your infrastructure grows in complexity, nested stacks help maintain modularity and reusability. You can break your architecture into logical components, like VPC, compute, or monitoring, and reuse them across projects or teams. To help keep things consistent, CloudFormation also offers drift detection. This feature allows you to detect when resources in your environment have been manually modified outside of CloudFormation, so you can catch and correct configuration drift early. Need to provision something not natively supported by CloudFormation? That's where custom resources come in. By integrating Lambda functions, you can extend CloudFormation's capabilities to support virtually any resource or external system. To protect critical resources, CloudFormation allows you to set stack policies. These policies define what actions are allowed or denied during stack updates, preventing accidental deletion or modification of important resources. And finally, for teams building their own reusable infrastructure modules, the CloudFormation Registry provides a central location to create, publish, and manage custom resource types, both private to your organization and publicly accessible. Now let's talk about the AWS Cloud Development Kit, or AWS CDK, a powerful tool that brings modern software development practices to the world of infrastructure. Traditionally, defining cloud infrastructure has meant writing long YAML or JSON templates using AWS CloudFormation. While effective, these formats can be verbose and difficult to manage at scale. With CDK, you can define your infrastructure using familiar programming languages like TypeScript, JavaScript, Python, Java, C#, or Go. This means you can use the same language you use to build your applications, making infrastructure code easier to write, understand, and maintain. The AWS CDK also enables object-oriented programming, so you can create reusable constructs, just like functions or classes in your application code. You can package and share these constructs across teams, encouraging consistency and reducing duplication. To make things even easier, CDK provides a rich constructs library that includes pre-built components for common AWS patterns. Whether you're spinning up an API gateway with Lambda integration or building a VPC with public and private subnets, you can use well-architected blueprints to get started quickly and follow AWS best practices. The CDK also provides high-level abstractions that let you focus on your intent rather than low-level configuration. Instead of worrying about every individual resource, you define what you want, and the CDK handles the details. Because you're writing code, you also benefit from type checking and compile time validation, catching many errors early before you deploy. This makes development safer and faster. To streamline deployment, CDK includes CDK pipelines, a construct library that helps you set up self-updating CI/CD pipelines for your infrastructure. Once configured, your pipeline handles everything, from build to test to deployment, automatically. And under the hood, all CDK applications synthesize into AWS CloudFormation templates. This means you get the reliability, security, and maturity of CloudFormation, while enjoying the flexibility and expressiveness of modern programming languages. A crucial part of modern DevSecOps practices is integrating static code analysis into your CI/CD pipelines. This ensures that code quality, security, and maintainability are automatically evaluated as part of your development workflow before code ever reaches production. To start, one of the most popular tools for static analysis is SonarQube, and it integrates seamlessly with AWS CodeBuild. SonarQube automatically scans your source code for bugs, vulnerabilities, code smells, and duplications. You can include it as a step in your build process to ensure quality checks happen early and consistently. For a more advanced AI-powered approach, Amazon CodeGuru brings machine learning into the equation. It reviews your code and provides intelligent suggestions to improve performance and detect hard-to-spot bugs. CodeGuru continuously learns from millions of codebases on AWS to offer context-aware recommendations, saving developers time and effort. In addition to full-scale analyzers, language-specific linting tools such as ESLint for JavaScript, PyLint for Python, or CheckStyle for Java help catch formatting issues, enforce coding standards, and flag potentially problematic code patterns. To enforce discipline in your development lifecycle, you can set up quality gates. These are criteria, such as minimum unit test coverage or maximum allowed complexity, that must be met for the pipeline to continue. If the code doesn't pass, the deployment is halted, ensuring only high-quality code is shipped. You can also incorporate tools like OWASP Dependency Check to analyze third-party dependencies for known vulnerabilities. This helps mitigate risks from external libraries and frameworks by alerting you to insecure versions before they're deployed. Beyond code syntax and dependencies, some teams use tools like ArchUnit to enforce architectural rules. For example, making sure certain layers or modules don't depend on each other directly. As we progress in building secure and reliable applications on AWS, Dynamic Application Security Testing, or DAST, plays a vital role in identifying vulnerabilities in your applications, not just in the code, but in the actual running environment. A common way to start is by integrating OWASP Z Attack Proxy, or ZAP, a popular open-source DAST tool, directly into AWS CodePipeline. With this setup, you can automate security scans during your deployment pipeline. ZAP emulates an attacker's perspective, probing for issues like SQL injection, cross-site scripting, and other common web vulnerabilities before they reach production. If you're developing APIs, tools like Postman can be extended beyond functional tests to include security test cases. You can automate tests that validate authentication flows, input validation, and ensure that access controls behave as expected. Another proactive step is to validate your AWS WAF, Web Application Firewall, configuration in pre-production environments. Before you rely on WAF protections in production, run simulated attacks and verify that the configured rules actually block malicious traffic. Fuzz testing is another dynamic technique to discover unknown or unexpected vulnerabilities. By generating random, malformed, or unexpected input, fuzzers can uncover edge cases that regular tests might miss, often surfacing bugs that would otherwise go undetected. If you're using containers, integrate container image scanning tools into your pipeline. Services like Amazon ECR or third-party scanners can detect known vulnerabilities in base images, packages, or dependencies, helping you shift security left in the development cycle. It's also important to build regression tests for security. Once you fix a vulnerability, create automated tests to ensure it doesn't reappear in future builds, making security part of your continuous validation. Finally, manual penetration testing results shouldn't be forgotten. Take findings from red team exercises or external assessments and feed them back into your automated testing workflows, ensuring long-term remediation and accountability. This illustration represents a modern, fully automated CI/CD pipeline built on AWS, a powerful architecture that streamlines the path from code to production. It all begins when a developer commits code changes. These changes are pushed to AWS CodeCommit, a fully managed source control service that securely hosts private Git repositories. Once the new code is committed, AWS CodePipeline springs into action. Acting as the orchestrator, it automates a sequence of well-defined stages that carry the code through the software delivery process. The first major stage is CodeBuild, AWS's fully managed build service. Here, the source code is compiled, dependencies are resolved, and the application is packaged. But the process doesn't stop at compilation. CodeBuild also runs static code analysis using tools like SonarQube. Once the build succeeds, the pipeline advances to the CodeDeploy phase. During deployment, the application undergoes dynamic analysis using OWASP. With tests and scans passed, the code is then deployed to AWS Elastic Beanstalk, a fully managed service making deployment fast and efficient. Throughout this workflow, AWS services work together to provide full lifecycle support. Amazon SNS sends real-time notifications. Amazon CloudWatch monitors logs and performance metrics. AWS CloudTrail records API activity for security auditing. AWS Config ensures all deployed resources remain compliant with company policies. and AWS Systems Manager helps manage configurations and operational tasks across environments. Together, this integrated tool chain ensures that every code change is automatically tested for quality, validated for security, and deployed reliably, all while maintaining compliance, observability, and operational control. As teams grow and applications scale, the need for more advanced CI/CD patterns becomes critical. AWS provides the flexibility and tooling to support sophisticated deployment strategies that improve reliability, speed, and security. Let's explore some of these patterns that help elevate your software delivery pipelines. First, consider trunk-based development combined with feature flags. This approach enables developers to merge code frequently into a shared branch and deploy continuously without exposing unfinished features to users. Feature flags act like switches, letting you turn features on or off dynamically, so you can deploy to production with confidence and control. Next, to reduce feedback time and detect issues early, you can set up parallel test execution. Whether it's unit, integration, or acceptance tests, AWS CodeBuild supports running them in parallel, helping your team catch errors faster and speed up the development cycle. For safer deployments, canary deployments are a powerful pattern. They allow you to release changes to a small subset of users before rolling out to everyone. Another pattern is multi-region deployment. By deploying your application across multiple AWS regions, you can ensure higher availability and better performance for global users. CodePipeline and CodeDeploy both support cross-region deployment workflows. You can integrate security scanning into pipeline stages, such as static code analysis, dependency vulnerability checks, or container image scanning. This enables you to catch security issues early, before they reach production. Before deploying infrastructure changes, it's important to validate them. Tools like CloudFormation Guard let you run infrastructure compliance tests, ensuring your configurations meet organizational policies and security standards. Lastly, don't forget the value of pipeline artifacts. These are the outputs of your build or test stages, like binaries, reports, or templates, and they provide traceability. By storing artifacts at each stage, you maintain a clear chain of evidence from the original source code all the way to the deployed application. One of the key strengths of the AWS Developer Tools ecosystem is how seamlessly it integrates with the broader range of AWS services. Let's start with AWS Lambda. With CodePipeline and CodeDeploy, you can automatically deploy updates to your Lambda functions. Each deployment supports versioning and aliasing, allowing for safe rollbacks and blue-green deployments, ideal for serverless workloads that require agility and precision. For containerized applications, AWS provides native support for Amazon ECS and Amazon EKS. Whether you're running containers on Fargate or Kubernetes, you can plug your pipelines directly into these services and deploy Docker images with confidence, using automation and deployment strategies like rolling updates or canary releases. When it comes to front-end applications, Amazon S3 is a great choice for hosting static websites or single-page applications. You can automate the upload and deployment of your web assets using CodePipeline, ensuring each commit goes live with minimal delay. To simplify serverless application development even further, AWS offers the Serverless Application Model. SAM helps you model, build, test, and deploy serverless apps using a streamlined syntax and integrates directly with AWS Developer Tools, making it easier to handle complex serverless stacks. Managing application configuration securely is crucial, especially across multiple environments. That's where AWS Systems Manager comes in. You can store parameters, secrets, and configuration values securely and pull them into your applications dynamically at runtime. No hard coding needed. Once your application is live, you need visibility. Amazon CloudWatch gives you a comprehensive observability suite, offering logs, metrics, and alarms to monitor application health and performance. And to understand what's happening inside your distributed applications, AWS X-Ray offers end-to-end distributed tracing. With X-Ray, you can pinpoint bottlenecks, debug errors, and analyze performance across services, making it easier to optimize complex architectures. In modern cloud environments where infrastructure is dynamic and changes are frequent, maintaining security and compliance is not a one-time task. It's a continuous process. AWS Config is a fully managed service that enables you to continuously evaluate the configuration of your AWS resources. It tracks the state of your environment and checks whether your resources conform to predefined rules, automatically and in real time. You can start with managed rules, which cover a wide range of best practices and compliance needs, or go further by creating custom rules using AWS Lambda. These custom rules allow you to implement checks specific to your organization's requirements, like enforcing encryption on S3 buckets or tagging policies across EC2 instances. But evaluation alone isn't enough. With AWS Config, you can automatically remediate non-compliant resources. For example, if a public S3 bucket is detected, a Lambda function can be triggered to remove public access, closing the compliance gap immediately. AWS Config also tracks configuration changes over time, providing a complete timeline of who changed what and when. This is incredibly valuable for troubleshooting, audit readiness, and forensics. To streamline compliance at scale, AWS Config offers conformance packs, collections of rules mapped to specific compliance frameworks like HIPAA, PCI DSS, NIST, and SIS. These packs make it easy to adopt industry standards with minimal effort. And if you're operating in a multi-account setup using AWS organizations, AWS Config can enforce consistent compliance policies across all your accounts, ensuring governance at the enterprise level. By integrating AWS Config into your DevSecOps pipeline, you're not just meeting compliance, you're automating it. This brings together visibility, governance, and remediation into one unified approach for continuous compliance in the cloud. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.